Okay, yeah. All right, so what we're going to do now is we're going to take a look at the tangent function. So we started out this chapter looking at the sine function, and then we looked at the cosine function in the last section. Now we're going to look at the tangent function, okay? The tangent function is not your friend. It has a very strange looking graph. It's different than both sine and cosine. It's not very easy to work with, but you at least need to just be familiar with the general idea here. We don't really use the graph of the tangent function very much in higher math classes, so it's not super duper important, okay? All right, what you have to remember about the tangent function, the way we're going to derive it, is if I take and make a little right triangle here in my unit circle, tangent is, bless you, what over what?
Oh wait,
opposite over adjacent. And so if the coordinates of this point are x, y, the opposite side is going to be what? Y, and then the adjacent side is going to be x, okay? So in terms of the unit circle, tangent is y divided by x. So we're going to do the same thing we did for the sine function. We're going to sort of trace this as we go around the graph and see what it looks like. So right here at this very first point, which would be 0 radians, 0 degree angle, what are the coordinates of this point? 1, 0. So if I go y divided by x, if x is 1 and y is 0, what do I get? 0. So that means the tangent function starts at 0, okay? But then here's where something funky starts to happen. What is the angle measure up here right on the top of the y-axis? How many radians? Tangent will be defined there. Yeah, what's the radian measure right here? Pi over 2. Okay? Remember, this is pi over 2, this part is pi, this is 3 pi over 2, and that's 2 pi. So at pi over 2, something bad happens, as Mary pointed out, because the coordinates of this point are 0, 1. So if I try to go y over x in this case, I'm going to try and go 1 divided by 0, which is undefined. And so what that means is, unfortunately, there is a vertical asymptote right here at pi over 2. Okay? And that's part of the reason why I said the tangent function is not a friendly function, because it has asymptotes in there. So we need to go back a little bit and see what's happening in between the y-axis and this first vertical asymptote. So if I take a look at this point right here, the x-coordinate there is going to be what? Estimate.
0.9.
Yeah, 0.9. It's going to be just a little bit less than 1. And the y-coordinate here will be a little bit bigger than 0. So if I go y divided by x there, do I get a big number or a small number? I have a small number because the y-coordinate is much smaller than the x-coordinate. But when I come around over here, then the situation switches. What's the x-coordinate right here? 0.1. Yeah, just a little bit something bigger than 0. And what would the y-coordinate be here? 0.9 or something bigger, okay? So if I go this time now, 0.9 divided by 0.1 would be a bigger number. And so what happens in between the y-axis here and the asymptote is that the value of that ratio y over x is going to increase. What's that? But it never touches, no. So what that means is I can find an x and a y coordinate on this circle that will have as big of a value as I want, but it will never be, it'll never be 1 or 0 or whatever. You know what I'm saying? I can't, as soon as I get to here, then I'm undefined, okay? All right, so what happens on the other side of this asymptote here? So let's take a look at a point just to the left of the y-axis. What is my y or x-coordinate going to be then? It's going to be negative something really small. And what's the y-coordinate? Yeah, still positive something big. So when I take a big positive number and divide it by a very small negative number, what do I get? Yeah, negative something really big or really small, depending on how you're thinking about it. And so that's going to be way down here, okay? And then when this keeps moving around again, when I get to pi, since the y-coordinate at pi is 0, at pi, once again, we will have a place where it crosses the y-axis or x-axis, okay? And so the graph is going to look like this, okay? Yeah, and it's just going to keep doing that, okay? And so on the other side here, the graph looks the same way, and it's got a vertical asymptote over there also, okay? So the tangent function is not connected, it's not continuous. There are breaks in the graph. So each one of these pieces is a separate piece of the tangent function, all right? Like I said, it's not pretty, okay? What's the period of the tangent function? How far does it take to go from there to there? One cycle of the graph. Pi, all right? And so that's different from the sine and cosine functions. Their periods were both 2 pi, but for tangent, the period is just pi. Okay? What is the amplitude of the tangent function? How far above and below the x-axis does it go? It doesn't have one. It goes forever up above and forever down below, so it does not have an amplitude. Okay? And so, like I said, it is not a very friendly function at all. Okay? All right, so if you were asked to sketch a graph of
such a whiny voice.
So let's sketch 2 cycles of the tangent of pi theta, just like we did before, okay? So, like I said, we're not going to start out with amplitude, because it doesn't have an amplitude. So really all we need to know is what the period is of this thing. The period of the original one is pi, but what's b in this case?
Theta. What?
Pi. The number in front of the variable is always b. And so in the other ones, we found out the period by going 2 pi divided by b, because the period of our original function was 2 pi, but the period of the tangent function is what? Pi. So to find the period of this graph, I have to go pi divided by pi, which is 1. Okay? So this is going to have a period of 1. Okay? Now the dumb thing is that in order to graph this, since the y-axis splits it in half, that means I have to go -1/2 this way and +1/2 that way to get one cycle of the graph in there. And then you just draw that fun thing right there. Okay? But they said they would like us to sketch 2 cycles of it. So the next thing I'm going to do is I'm going to go all the way over here to what?
1.
Well, 1 is where it's going to cross the x-axis again. But my next vertical asymptote is going to be 1.5. And then if I draw that in there, then there are 2 cycles of that function. Okay? So that is not a pretty one to work with. For now at the origin, yeah. We're going to shift it around a little bit later.
Is it always going to be like in that, is it ever going to flip and like?
Yeah, we're going to mess around with that more later, but for now, not so much. Okay, so let's do another graph here. So this is going to be tricky. What's the period of this graph?
Pi over 3.
Pi over 3. Okay, because b is 3. It's the number in front of the variable. And for a tangent graph, you go pi divided by that. Sine or cosine, you go 2 pi divided by that. Yeah. Okay. So pi divided by 3 is just pi over 3. Okay. Now the tricky part though is that means that from here to here has to be a total distance of pi over 3. So it's pretty easy for me to just draw the graph. It's going to look the same every single time. The question is, where are those asymptotes happening? Okay, and so if this distance right here has to be pi over 3 total, then this distance here has to be pi over 6. Good. So that would be pi over 6, and this would be negative pi over 6. Okay? And then this distance right here is also pi over 3. So if I'm starting at pi over 6 and then I have to add another pi over 3 onto there, then pi over 3, I'll have to get a common denominator. How many 6 is pi over 3? 2 pi over 6. So I'm really going pi over 6 plus 2 pi over 6, right? Because I doubled the bottom to get 6, so I have to double the top. Okay? So that's 3 pi over 6, which reduces to pi over 2. Okay? So my vertical asymptotes in this case will be at negative pi over 6, pi over 6, and pi over 2. Okay? Okay, one more thing that we can do that's easy with these is you can figure out values of the tangent function using the unit circle. So if I wanted to figure out the value of the tangent of pi, where is pi on my unit circle?
At the 180 mark.
At the 180 mark right here. The coordinates of that point are
Negative 1, 0.
negative 1, 0. And so since, as Lane pointed out, tangent is y over x. What's y over x in this case? 0 over negative 1, which would really just be 0. Okay? If I wanted to find the tangent of, I didn't divide by 0, negative 5 pi over 6. Okay? Now things are getting a little bit tricky. How do you want to do that one? From my brain. I'm just asking you a different question now.
So what are you asking?
What do I do if I want to find the tangent of negative 5 pi over 6?
Well, first you have to find the point on there.
You have to find the point on the unit circle. Anybody know how many degrees negative 5 pi over 6 is? Anybody know how we can figure it out? How many degrees is negative 5 pi over 6, right? I need to multiply that by 180 over pi.
6 becomes
so the
1.
pi's cancel. 6 goes into 180 how many times?
30.
30 times. 30 times negative 5 is negative 150. So negative 150 means I need to go this direction and end up right there. Okay? What kind of a triangle do I have? I have a 30, 60, 90. Okay? So this side over here is going to be, the short leg is 1/2. And the long leg is root 3 over 2, because it's the short leg times root 3. Okay? So the coordinates of that point are, how far did I go in the x direction? Negative root 3 over 2. How far in the y direction? Negative 1/2. So if I want to find the tangent of that value, then I need to go y over x. What do I do when I'm dividing two fractions? Flip the second one over and multiply. So the negatives cancel, the 2's cancel, and the tangent of negative 5 pi over 6 is negative 1 over root 3. Okay? So we've done problems like this one before, where you have not this help. Well, we did, but not for a while. You have to take the radian measure, change it into degrees, use that to draw your triangle. Okay? And then what we did before was the x was just whatever cosine was, and the y was sine. Now you just have to go y divided by x. Okay? All right, piece of cake.
Taylor, what's the project? How do you even know?
I asked Ashley.
There's 3 mistakes. I did not know that.
That was ridiculous.